All right, so the formula, when you're asked to find the average value of blank, it could be the average value of whatever the word is, use the average value formula, okay? If it's this average rate of change, use the y minus y over x minus x. If it's this average rate of change, you're finding the crummy slope, okay? And it's about slope. Average value is about that y value. Like if you have a function that you're looking at from over a certain width, the average value tells you the length of the rectangle that would give you the same area as enclosed in the curve you're looking at. Do y'all see what I mean? So on sine from 0 to 2 pi, your average value will end up being 0. Okay? Because I shouldn't be saying the word area. It gives you the displacement. Okay? So the displacement here would be 0. And so your average value would be 0. The word value in math means, and calculus means y. Alright? So, see how long my voice lasts. So the formula is 1 over b minus a times the integral from a to b of f of x dx. And whatever this is, goes right there. The average value of blah, okay? Now, it also could be written like this. Which I really strive very hard for you. You know, it really even takes more time than I maybe should be doing sometimes to get you to understand what you're doing. So you don't have to memorize so much, and so you're not quite so foggy as I was in calculus. Do y'all see how that makes great sense if I want an average? What is this? What does the S mean? You're taking a running total and you're dividing it by the distance that you went. So it's like adding up all the tests and dividing by 14 to get the average. Okay? So, in fact, when you say something like you've gone 50 miles an hour, that's an average rate of change, isn't it? You probably didn't go 50 miles an hour. You may have gone 300 miles in a total of 0 to 6 hours. Do you see how it's an average value? Okay. All right. And at some point today, I wanted to show you this anyway. I think I'll do it right now, and then you'll see it again. I don't think I did this the other day. But y'all see that's the average value formula. I usually write it as 1 over b minus a. Okay. According to the fundamental theorem of calculus, though, this goes backwards. If I write it with an F to capital F, and gets displacement. Whoa. What did it just turn into? Slope, isn't it? So they're tied together. I told you, and even in your book, you saw the mean value theorem for integrals. We call that the average value theorem. But we're just splitting hairs when I say one's the MVT and one's the AVT. In AP, if we say MVT, we're talking about for derivatives. But you see, even the average value formula still takes us to the same result, a different way. It's finding the average rate of change. Why does this take me to a rate of change? This would be like adding up, if this is velocity for a certain time, it would be adding up all the miles I went. And what's b minus a going to be? Would be my time. So do you see, while this gives me, not total distance, by the way, it gives me displacement, okay? And then when I go back and divide by b minus a, I'm going back to a rate. So average rate of change, your average value formula is a rate of change. So let's just pause and think about that. I don't know if I really got that point across because I can't talk. But do you see when you come back and divide by this, you're coming back and dividing by the time that's elapsed. So it goes back to a rate. So they're both average rate. Okay. All right, now, let's look at the first homework problem. What was the first one I gave you? 47. All right, so it said, find the values guaranteed of the mean value theorem for intervals, which is the average value theorem for the function over the given interval. So I have f of x equals square root of x. From 4 to 9. And if I want that mean value theorem for intervals or the average value, I'm going to do this. So I get 1/5, and then I'm going to work this out. This is x to the 1/2, so that's x to the 3/2 times 2/3 from 4 to 9. All right, so I get, I guess I go in and multiply the 2/15. Put in the 9. The square root of 9 is 3 cubed is 27. Put in the 4, and I believe that gives me 8. So this is 54 minus 16 over 15.
38.
Thank you, 38 over 15. All right, and then what do they want you to do with that?
X values original function.
Okay, so what'd you do there?
Or it being set equal to.
All right.
Like equal to the square root.
So what did you set equal to 38/15? Okay, so is that what y'all had a hard time deciding what to do? Because this is the average value. So I was just trying to pinpoint like why it was confusing.
I think the wording of the question was just weird.
I didn't
Okay.
understand like what C was, and then I just realized that C was the X value. And I was like, oh.
So is that what you did to get the right answer?
Yes.
And then when you squared it, that was your C value. I don't know what that is squared. Okay.
140.
I know the bottom, I don't know the top.
1,444.
1444.
Yeah. Over 225.
All right, so let's look at this. I think it's great. Obviously, you know, I think it's great to see a picture. Let me pull up the calculator. Square root of x from 4 to 9. Okay, so the reason I wanted to do one of the homework problems, at least talk about it after listening to y'all, is if they say find the average value, that would be 38/15. That was the y. When they start talking about C, A's and B's and C's, those are usually X values, which we did with mean value theorem and intermediate value theorem, okay? So you usually want to find out where that happens. And this calculator's always so slow. Okay, here we go. All right, so I have y equals, I should have probably just left those in there. All right, so I'm going to put in square root of x. And I'm going to make my window 4 to 9, which takes me from 2 to 3, doesn't it? Our average value was 38/15. So do we believe that? Looks pretty good based on the discovery thing I gave you the other day, the mashed potatoes. All right, so if I get a spoon and I start mashing on that, it's gonna morph over there and fill it up. And so it's sort of a, do you see why it's kind of an average? Because it's the same, it gives you all the incomes with us. Oh, did you get it now? Okay. Now, C was, trying to think of a way to do this. Where is it? Second draw. Maybe I don't remember how to do it then.
No.
Second, draw, line, oh, okay. I guess I never pushed that. Are you bored? This is kind of boring. This isn't even worth it, but now I'm just stubborn enough to keep going.
Yeah.
I've gone this far. Okay. Alright. So, do you see at some x value it actually does hit that average value?
Yes.
So it's like the mean value theorem in that you get this crummy slope, and somewhere in between there it actually hits that maybe more than once. That's also happening with the mean value theorem for integrals or the average value theorem. So actually at some point in there, you just found where it actually hits that y value. So that's what you were doing. Okay. All right. Now, any other homework questions that you didn't figure out on your own?
Can we do 48?
Let's look at 48.
I got like a square root of something you can't take the square root of.
All right. 48 is the integral of x minus 2 root x. And I'm going from 0 to 2. Morgan, you missed my awesome picture.
Told you. I told Emily I don't want to go to the bathroom because I'm going to miss something.
This is what it did.
Sorry, I'm just gonna
So we have this. Is it still up? It's still
It
up.
was like really fun.
It's awesome. Well, I just worked so hard on it. I want to show you again. I didn't know I was gonna have to open it
I
again.
know that.
Her hair looks really nice.
Really?
She looks really pretty, but like she's so sad.
What mustache? She looks a lot younger.
No, she's probably just really sad. She really wants to go.
Yeah, she did it.
Is it ever gonna open? Why did I close it?
Did she actually get it in now?
All right. Well, we'll see if it opens in a minute. All right. Now, this is gonna be x squared over 2. This one I'm gonna add 1 and get 3 halves times 2/3 from 0 to 2. Don't forget this 1/2 out in front of the whole thing. Top minus bottom. Okay. When I fill in 2, I get 2. And here, I'm gonna get 4 times the square root of 2 cubed, which I think will give me 8 root 2 over 3. And don't forget to fill in 0. You'll see that you'll be tempted to get lazy, other than I say it every time. Don't neglect filling in 0. You don't always get 0. Do you might check this answer on Slater? Okay, so let's see what I get. All right, so
It was negative. I got 1 point.
all right, so I get 6 minus 8. 6 minus 8 root 2 over 3.
That value is negative 0.8.
And that should be, let's see if my calculator decided to open. All right, so here it is, Morgan. I put in y'all's number 1444 over 225. And that's the x value where it hits that high. Okay. All right, so we get 0.5 times 6 minus 8 root 2 over 3. Is that right?
Yeah, that's what I got.
Okay, and then you want to know where your equation equals that. So,
Yeah, this is the part I got.
I'm gonna go here, I'm gonna hit store, and I'm gonna store it for A. Don't ever store anything for S. Alright, so then we go to Y. You should. Well, it matters a lot more on the TI-89 than on the 84. But I would store it for something else. You push X so often on your calculator. It's best to save it for other things. What was the equation?
X minus 2 square root of X.
And I want to know where it equals A. My window was 0 to 2.
Yeah.
And I can go to table. And I think at 0 it was 0. And at 2 it was negative. So I'm going to go negative 2. I don't not see anything. Oh, X min and max.
If you want negatives, let's say right.
I can't wait to go skiing. Me too. I haven't skied since last, I haven't skied since
skiing
March.
Yeah.
I haven't skied since the ski trip. That was the best.
I skied a
It's a
couple
great
weeks
like
ago.
that.
So it looks like there's going to be 2 times.
Yeah.
Yeah.
But I didn't know how to go this time.
Alright, so you got a second count intersect.
Oh, that's it. Okay.
And don't always just go first curve, second curve, and enter. After you need to intersect, if you've ever done it, a lot of times your algebra teacher just goes enter, enter, enter. First of all, you know a lot more about tangent lines and how this program's probably working. So you need to be over there close to it so it's following the right tangent lines to connect it. Another thing is you might have 3 equations in there, and you gotta manage which ones you're talking about. Like right now, I'm going to reason that y equals like negative 1/2 in there. But suppose that I wanted to know something about that too. So let me change that. Okay. So it could be I'm working a problem where you will be, not could be. When we really get to area enclosed, you might want the area enclosed, like of this weird shape that's made, captured between the black, the blue, and the red. And using your calculator, you might have to find those intersections, okay? So when I go to second count intersect, if I want that one, do y'all see right now I shouldn't even push enter? And this is coming very soon, okay? So before I get there, I can use my up and down arrow key to jump equations. Once I'm on one of the ones I want, I hit enter. And then I wait and see if it's on the next one I want. If it's not, I can manage it before I hit enter. And then I always just hit enter for guess.
So can you figure it out algebraically, or
I'll
can you
look at that in just a
use-
minute.
Okay.
Was it 0.438? You might look it up.
Yeah.
Yes.
Okay. And then was there another one?
Yeah.
Yeah.
So then I would go to second count 5. And first curve, I need red and black. It can be real aggravating to move this. So you do have the option just to go over there faster. Oh. Well, you do, but it's not right now. Anyway, let me move on. I'm not gonna find it right now. What's the other one? I would move over there closer. 1.7? 9. Okay. All right, let's look at it algebraically. Oh, wow, that'd be shocking if we could.
Right?
X minus 2 root x
Yeah.
equals 1,
It was.
6 minus 8 root 2 over 3. So I guess, oh, well, I couldn't do it. We might could pull it off with the quadratic formula. Well, girls, they would never expect you to be able to do that, okay? But I do want to talk about this in light of something we're going to do later today. I don't know why it always wants me to do this twice before it gives me extend page. Well, I still don't see extend page. Okay, anyway. So if this was an integer, you would maybe be expected to do what I'm about to do. I can let u equal root x. And so what is this? U squared minus 2u equals that number. But you see if that was a number like 5 or 6, could maybe pull it over and factor. And then go back and sub back in for that and square it. Y'all see what I mean? I mean, with that kind of number, there's no way I'm going to be able to factor it. Okay. So, I would go straight to my calculator when you have calculator active problems. All right, other questions? So it's a lot on average value. Okay? All right, now I want to talk about something that I've mentioned a couple of times. That,
Yep.
I had to check her fingers to make sure everything was okay.
Yeah.
Yeah, the first time I saw it, I was like,
One of my ninth graders sent me this Timothy.
Chalamet?
Yeah. But in one of the pictures he's smoking. I'm like, no. I'm gonna put that in.
You know,
I think I was pointing at my face, so look at me crying.
Yeah, I just don't.
Why are you trying?
Because it was the after the last show in syndrome, so like all the seniors are
And
graduating.
Brandon, Morgan's mom.
Yeah, that is Morgan's mom, and that's Katie Tanner right next to me.
Her nose.
Yeah.
All right. So anyway,
Is that Morgan's mom in the back?
Yep.
math teachers sometimes say things that we don't really mean, like anything to the 0 power is 1. I always try not to say that. Okay.
0 to the.
I always say almost anything to the 0 power is 1. 0 to the 0 power is undefined. It doesn't make any sense whatsoever. Okay? It's actually like 0 over 0. It can give us like a hole in the graph, and I'll get there later. Absolute value doesn't always make a V, but we sort of lead you to believe that at first, right? The absolute value of a line makes a V, and the absolute value of every line doesn't make a V. Like technically, I guess this is a line, isn't it? Y equals that, but that would just be a horizontal line, it wouldn't be a V. So we gotta be careful with what we say. I've been throwing around the word area and distance in a really bad way, and it started to bother me, okay? So, if you have the velocity of something, what's coming very soon is they're gonna say, what's the total distance traveled during the first 10 minutes? Well, how can you get from velocity back to distance? Take the antiderivative, which we know if we can means take the integral from 0 to 10. So really bad idea, okay? So, there's a marathon that I ran sometimes in Mississippi that you go out 13 miles on the Natchez Trace and then you come back 13 miles. It was my fastest marathon because I could not wait to be finished. It's so boring. It's like the Natchez Trace is a protected highway, and so there's no buildings, no exits, so much cows and trees, which is really pretty to drive. But, if you're just chilling, listening to music, but oh my gosh. And then if you have a wind one way or the other, you're gonna have it for the whole 13 miles. Anyway, I'd be so mad at you if you saw me in the parking lot and a few hours later you come back and you see me in the parking lot and you go, thought you were gonna run the marathon today. I'm like, are you kidding me? I just ran 26 miles. Look at me. Hopefully I look like I didn't look 3.5 hours ago. Okay? Do y'all see what I mean? Like, well, you'd be so mad if I saw you going out for practice, which I do often, look out my window and see people, you always go on the bridle path or something. But if you were running down Fifth Ave and you ran all the way down to 14th Street, and then y'all did something fun like stop and look at the Christmas tree at Rockefeller Center. And then I leave school and I go see the Christmas tree at Rockefeller Center. And I see y'all there. I'll go, oh, well, you ran 2 miles today. All I know is your displacement, right? All I know is where you started and where you stopped. You would love all of this credit, wouldn't you? When you want to go, Miss Lazari, the coaches made us run 10 miles today. Isn't that a bit much? Okay? Do y'all see what I mean? So, please don't, for area or distance, don't just slap this on. You're gonna have to look at the signs of your velocity. And if you're going in a negative direction for 5 minutes, you would integrate it from 0 to 5. But what would you do with your sign? If your velocity is negative, but make it you would switch it to positive by negating it, because you want to add that in. And then when you're going to positive velocity, you can just add the rest. Do y'all see what I mean? Same with area. If I ask you the integral from A to B of that graph, and this is 2 and this is 3, which I realize is drawn very poorly, the integral of that would be -1. Integrals just keeps it running total. But what would the area be? 5. So you better check your equation before you integrate it to see if it ever goes negative and find that breaking point. Y'all see the difference? Now, if it's a calculator active problem, what could you do? Somebody mentioned this the other day. If it's calculator active, what could you do? Absolute value. That'll always work if it's calculator active. All right, so that wasn't really part of today, so let's move on. Did I give you all any other handouts last class? Okay, hang on to that. We'll get to some of those. In fact, you might do that right now. Let me see what it is. Is it back in front or just that? Okay. So let me give you this. All right, so everybody, make sure you get one of these. And I guess there should be one extra for him.
Like pepper, cheese, like
It was just grilled green cheese. This was just cheese and like green cheese. And chicken noodle soup.
Does anybody volunteer to go really fast and get a nose up for me in the mess?
I can do it.
Because I can't do it fast.
I'll do it. You would laugh at, oh, and then I can
Y'all can go together. This game might be kind of fun.
Oh,
So,
if both of us are there, we can.
yeah. So I'm sitting in my chair. Okay.
Okay.
And right here are a bunch of old binders.
Behind you?
Yeah.
Okay.
I know.
And
Do you need a solution book?
no,
Okay.
as close to that.
I know where that is.
Back here are some binders on the second shelf. And there's a white one that's got all my calculus stuff in it. That's vertical.
Well, look.
But I hope there's not more than one white
So
one.
are we reading the bottom?
So if there's 2 white ones, just bring them up.
Very well.
Or open one of them.
We'll see.
Hey,
If one of
no.
them's obviously not.
Yeah, it's got hot
Put
pink,
it
like,
up here.
put up papers in it.
Okay.
Good luck.
Thanks.
Alright, we might need to go to the bathroom or. Here, I'll pass these on to you. Oh, wait. These extras. Alright, and I think you need these also.
Why did you guys put in one subject for this one?
I don't think this is in that packet.
Just give you one. No, stop. I would go first. But like, imagine English class, you have to read the whole book.
For a day.
Oh my god. Stop. I'm math.
So basically, you just want to take math and nothing else.
Is that what you want to do?
Yeah, that's why they don't want to go.
No, I just
I didn't realize that she was on house probation and she didn't come to house. I thought she just wasn't showing up at the house. She got house probation? Yeah.
I thought they installed that last year.
Well, I mean, she that deserved house probation.
Oh.
Her friend almost died. Who was the one that almost died though?
Were you not in that chapel? I was, but like, I
What did
wasn't.
she say?
Actually,
That was so
almost
funny.
died.
Yeah, she was just like, I was
Wait,
like, who was it? Like the one she gave the.
That was also like the very first revelation.
Yeah.
You were paying attention to chapel? Yeah.
Nobody loves chapel like me and Emily do.
Chapel is the best time.
There was this one chapel
sit there,
but I remember like turning around and you were laughing. There was this. I was gonna talk about. You know what I was gonna say? Okay, never mind.
Success.
You had 4, but
Oh, there were
one
4.
said social events and the other said 16 prep. So I think
Okay,
it's this
thank
one,
you.
but I'm
It's
not
this
sure.
one.
And then
Thank you. So I'll know it's that. Okay. With the Memphis, Tennessee address on it. All right. Thank you so much. All of my notes are right.
How long have you had that? Like,
Yeah.
Since like 2006, 8. But it's so awesome. I just got so much that I use over and over again. Okay, so looking at your staple page first. This is really where it says fundamental thermocalculus. If you write just first in front of that. First fundamental thermocalculus, okay? Just like this, first. All right. So method 1, my job here's the derivative, and I want to find y of 3. I could let y'all run with this before I taught you anything recently. Well, maybe. I think even given, some of y'all could have thought backwards to the y values. But now you know how to take an antiderivative. So, by the way, girls, this is called differential equations. If they give me a derivative and I start going backwards. Differential equations is an entire course that engineers take and math majors take. In college, people call it weird things, like there's always names for stuff. Diffie-Q, analytical, or DE, differential equations. You'll see when you get there and you'll laugh when whatever your friends are calling differential equations. Alright, so it means you got the difference quotient and you're going backwards. So to go backwards, this would be 3x to the third over 3 plus 4x squared over 2 minus 5x. The plus c is so important, okay? Because if you have the derivative, you're not going to know anything about your constant, right? Did y'all get that?
Yeah.
Any equation like this is going to have that derivative, no matter what the constant was.
Yeah.
All right? So you've got to put in plus c. All right, so now I'm going to fill in, if you're ever given a point, fill it in for x and y, okay? So I get -1, let's cancel these, when x is 2. I'm going to call this 2x squared minus 5 times 2. So what does this enable me to do? It enables me to solve the differential equation. I will now know the exact equation that we started with. So you heard me kind of stumble through that because right in the middle I thought of a good example. Did y'all know the old birthday party game, Pin the Tail on the Donkey? Okay? There's a lot of functions.
You put a blindfold
Forgive her,
on,
she's
and
Spanish.
little kids. No. You spam the kids, and then there's a little picture of a donkey, and then you're holding the tail, and there's like a sticky end on it, and then you like the kids are blindfolded, you spin them around, and then you're like put it somewhere, and then they have to guess where the tail.
And then you have to try to pin it as far away from really weird.
We so have to play that when the exam's over.
Like, what?
I need to go buy one. We need when the exam's over.
We literally
And I'm gonna pretend like we're still gonna do calculus.
Yeah,
Um,
there's
We'll play
Yeah, because it's all
chocolate
for you.
games.
we go to the park and like.
Advanced chemistry is taking a field trip to the Bahamas.
Yeah, we are. No big deal.
You are kidding. Okay. Girls, look.
But we talked about it.
I don't know what this looks like. It's parabola of some kind. Don't all of these parabolas have that derivative? Oh, I'm sorry. My original would be an x cubed. Okay? Sorry. Okay, so just pretend like this is a function up here. Don't relate it to this at all. Here's a bunch of functions. Would they all have the same derivative? If this was x squared minus 1, x squared plus. But once I give you a point, you know exactly where, once I give you a point, you, oh gosh, come on. Once I give you a point, you know exactly where that thing lies. I didn't really want all of this to go through. I'm struggling. Okay. So once I give you that point, you know exactly where it is. You see like pin to tail, if you knew what pin to tail on the pumpkin is. You've got this like shape. If I give you 1 point, girls, if I give you 1 point, it locks it in. Okay? All right, so -1. To do this every time. All right, so I have -1 equals 8 plus 8 minus 10 plus C. So it looks like C is,
I got -7.
yeah, this will be 6. So C is -7. All right, and I don't think it's letting me extend page. So I'm going to go ahead and put it in. Let me see. Okay, so now I know it was y is equal to x cubed plus 2x squared minus 5x plus c. And our question was to find y of 3. So now I can do it with my differential equation. So I can say y is equal to 3 cubed plus 2 times 3 squared. Girls, listen. Even if, oh, c was what, -7? That was real important. What I was saying is even if you have a calculator, you can do it in your head, you've got to see as a grader that you are, what number you're filling in, so do that. So I get y is equal to 27 minus plus 18 minus 15 minus 7. So that should be 23. So now I know, that once I solve my differential equation, I know everything I need to know about the real equation, okay? That's method 1. Let's go to method 2, using the first fundamental theorem of calculus. So this is method 2. All right, I'm going to take the integral from -1 to 3 of 3x squared plus 4x plus 5 dx. And I'm going to move Elena so that I can write something right here that's real important. Okay? Oh, where'd my equation go? All right. I'm going from -1 to 3, because what are my x values? Where are my x values? Super struggling. Where are my x values? Yes, Miss Lazari. It'd be 2 to 3. I was so convinced y'all were wrong until I looked back at my paper. All right, so my x values, I'm going from 2 to 3. All right. And according to the fundamental theorem of calculus, if this is the derivative, dy over dx, it's f prime of x. When I integrate it, will I get f of x from 2 to 3? Okay? So using the first fundamental theorem of calculus, I actually have an algebra problem. Let's keep going. I'm gonna do this. It gives me x cubed plus 2x squared plus 5x from 2 to 3. Why didn't I say plus c?
Because they're gonna
It's gonna cancel out. You could say it if you want to be in the habit. And what is this side gonna equal? Isn't it gonna equal f of 3 minus f of 2? Do you see how I'm using the first fundamental theorem of calculus? I'm telling myself if I integrate a derivative, it takes me to displacement of the original. For sure. Okay? Now I'm gonna find, sorry, that's an x. Top minus bottom.
Wait, isn't it -5?
Oh, maybe.
Yeah.
Thanks. Thanks for saving me there too. I need lots of saving today. Because it would have been highly unremarkable if I didn't got the same answer as A. Alright. Fill in 3, we have 27 plus 18 minus 15. Fill in 2, and you have 8 plus 8 minus 10. And what is f of 2? You know that. -1. Watch mine. Are y'all okay with that? Okay. So this part is 30, I think. Minus 6. How can I find f of 3? I'm looking for f of 3. Minus 1 equals f of 3. Do you see the fundamental theorem of calculus is working? That gives me 23. Same answer.
That's so cool.
It's super cool. You're gonna love all the things that you can do with that. Okay? So you could use method 1, differential equations, or you could use method 2, which is fundamental theorem of calculus, which means you're gonna take an integral. Anna?
So how do you know which method to use?
You can pick and choose, but sometimes they force it on you.
Okay.
So they
So
can do
there's
it.
no like benefit.
You'll see as we keep doing examples. I like the second one better almost 100% of the time.
It's one like period dependent.
I'm sorry, I'm dying. Yeah, but if you only knew one, this was necessary, and you'll see. Anna, also, as the time goes by, I'll point out when I would use the first one. Okay? All right, so this is what you were supposed to have seen here. That it's funny, once you see it, that you haven't seen the algebra equation before. If I integrate from A to B, f prime of x dx, let's use numbers. Let's go from 1 to 5. Would that give me f of 5 minus f of 1? Y'all see that? Everybody okay with that? If I integrate f prime, it takes me to f from 1 to 5, and I just went ahead a step further. So now do you see the algebra equation? If I want to find f of 5, if I know f of 1, f of 5 is equal to f of 1 plus the integral from 1 to 5 of that. Just an algebra. Very eye-opening as we go forward. All right, so let's move on. Let's go to the bottom part. All right, so we have f prime of x. That's not helpful. F prime of x is the sine of x squared. F of 2 is equal to -5. And I want to find f of 1. Everybody get out your calculators. Unless you happen to know the antiderivative of sine of x squared, which in case you do, we need to go and report it to the rest of the world that we have found it in this classroom. They love this function. If you had sine squared x, girls, it'd be way different than sine of x squared. Sine of x squared is a really weird function. So I can't think of anything, I think it has an antiderivative somewhere. It's just somebody somewhere's got to notice they took a derivative and ended up with this. I can't undo this one. I'll teach you some cool ways to undo some things that look kind of impossible. We still don't know this one. So this would be a calculator active problem, okay? Girls, even if you could undo it, if it's a calculator active problem, I preach. I want you to do it from the beginning on your calculator in its purest form. You see how many mistakes I made with my plus signs in my algebra, okay? So let's do it in its purest form. So I'm gonna say, I want to go backwards, sine of x squared dx. I'm gonna go from where I'm looking from, always use one of the numbers I gave you and the number you're looking for. So I wanna go from 1 to 2. That'll give me f of 2 minus f of 1. All right, so I cannot work this one to Anna's question, like, which one's better? However, that's a summation tool. It has an answer. So let's let our calculators find it. Push math 9. Sine, make sure your squared gets in there with the x. Oh, I'm sorry, do y'all see how to do math 9? Yeah. Put in your limits of integration. Make sure you're in radians. We'll know in a minute. Oh, yeah, because what's it doing? I told you it'd be slow. Some's different than others, I guess. Grace, sometimes yours will be slow too, though. No matter, you got a thinner one. You have a better operating system.
What'd you get? 0.4?
All right, did anybody get 0. Whoa, what'd you get?
No, I don't say 94945.
Okay, so it's positive 0.4945. All right, and then f of 2 is negative 5 minus f of 1. So if I add f of 1 to this side, and I say negative 5 minus 0.4945, then f of 1 is approximately equal to, or you could just say equal to, negative 5.4945. Super cool. You just found a value using the first fundamental theorem of calculus. It's so useful. It becomes an algebra problem. All right, let's look at the next example. Remember, if you didn't get that down, it's off as the class notes. I can only imagine how I sound with a southern accent and a hoarse voice. It's probably crazy. All right. On the next example, you have a picture that looks like this. Girls, whenever you see geometric shapes, you are supposed to use geometry. They mean for you to use geometry. But how would you even know to do that if you didn't thoroughly understand what the calculus integral means? Okay? All right, so this is f prime. They gave me that f of negative 2 equals 5. I want to find f of 0. So what I'm going to do, if I'm looking for f of 0, I'm going to let 0 be one of the limits of integration, and one thing I know be the other limit of integration. And I usually will go in order. Like here, I'm going to go from negative 2 to 0 of f prime of x dx. And that's going to give me f of 0 minus f of negative 2. Jumping straight to the first fundamental theorem of calculus. Gives you displacement of the original. So I understand where I'm getting this. I'm kind of jumping the fact that it's f of x from 0 to negative 2 to 0. I just go straight to this. All right, now can we find this based on what we know so far? What does this mean? Keep a running total from negative 2 to 0. And it's all positive, so that's okay right now. 1/2 base times height, what would that give you? 4. So this is 4. You would show your reader that as I'm grading your test right now, show me what you're doing, okay? F of 0 I'm looking for, and f of negative 2 is 5. So f of 0 is equal to, sorry, this is really ugly, 9. You actually know that you have the point 0.09 somewhere on the original graph. By the way, girls, the original graph will not look geometric. This slope must be some sort of linear function. Its antiderivative would be quadratic. There's probably, I'm guessing, a point of inflection or something right there on the original graph because my slopes change so drastically. I can also do increasing and decreasing from this. You can see how they can make this a whole free response problem pretty fast, okay? And I want to do that. You've been wondering this for weeks now, really. I keep eliminating them or going, well, what do you think? One day I'll show you how to do this. This graph goes from negative 2 to 6. From negative 2 to 2, the derivative is positive. And after that, it is negative, right? So that means my original is increasing and then decreasing. So it has a relative and absolute max at 2. Girls, the original, right? What's this absolute minimum? What's this absolute minimum? All we know is this thing's increasing and then decreasing. The minimum's got to be at where? One of the endpoints. Y'all remember that feeling? I've let you have it a few times. And I said, one day I'm going to show you how to find the value of those endpoints. I can actually use the first fundamental theorem of calculus. I can actually find f of negative 2 and f of 6. Okay? All right, we know f of 0 is 9. All right, b is f of 2. So I'm going to go from negative 2 to 2 of f prime of x dx is equal to f of 2 minus f of negative 2. So f of 2, I'm going to move a little bit faster now in interest of time. Does that give me 8? And doesn't it just double? You would show your work. But this is going to be 8. F of 2 was 5. So I'm going to have 8 plus 5. So f of 2 is 13.
But you mean f of negative 2, so yeah.
Thank you.
Sorry.
Is it f of negative 2? No.
No.
F of 2. I'll do the next one a little bit clearer than that, sorry. All right, f of 7. So use one you know. I have no idea if that turned into a 7 in my eyes. F of 6, there's not even a 7. The integral from negative 2 to 6 of f prime of x dx. And girls, you may be thinking, well, would you want to use like f of 2 now since you found it? I'd still go back to the givens in case I messed one up. I keep using the one they gave me. Is equal to f of 6 minus f of negative 2. This side is f of 6 minus 5. This side, we knew this was 8. And then what am I going to do for the semicircle, which is pi r squared over 2. This part is 2 pi. But what's the answer to this? 8 plus 2 pi or 8 minus 2 pi? It keeps a running total, so it's 8 minus 2 pi. Okay. So f of 6 is 13 minus 2 pi. So I knew my graph, my original, goes up somehow and down. Probably not like that. But the absolute minimum's got to be at one of these endpoints. I already know f of negative 2 is 5. Now I know f of 6 is 13 minus about 6. Even if it's 13 minus 7, wouldn't it be higher than that one? So this one would be my absolute minimum value. 5 is lower than whatever that is. Okay? Alright, I'm sorry, I forgot to ask all that. So B, find all values on the open interval where G has a relative maximum. I'm sorry, look at the next page, forget it. I forgot to have this in my hand. I'm really struggling. Alright, let's go to the next example. And I think you're fine, but let me give you the answer to this in case you want to look back on it when you're studying. A, f of 0 is 1. B, f of 7 is negative 4. C, f of 9 is negative 2. But I do want to do the last part of that one if I have time. Sketch the graph. So it's kind of like have very little information. We have a derivative f prime that looks like this, to 3, to 7, to 9. They're more semicircular than that maybe, but it doesn't matter because they told you each area, okay? I know f of 0 we found to be 1, f of 7 we found to be 9, and f of 9, f of 7 was negative 4, and f of 9 was negative 2. So on the original, on f, I have 0, 1, 7, negative 4, and 9, negative 2. Right, so I know that. I really could find a whole lot of points if I wanted to keep going. But it get bored at only day. Well, no, you couldn't. Because these aren't geometric shapes. So we have to only use the numbers they gave us. Alright, I could find f of 3. And, but they didn't ask me to do that. Alright, the first derivative is from 0 to 9, 0 at 3, and it's 7. And so it's positive, negative, positive. That means when I draw my function in a minute, that's going to be decreasing, increasing, increasing, decreasing, increasing. Now I'm going to do a second derivative chart from 0 to 9. Watch carefully. How will I get the second derivative from the first derivative? I got to treat this like its derivative. Where would its derivative be 0? You might need to look at your paper. Look at your paper and estimate it.
Like 1.5.
It looks about 1.5.
And then 5 and 8.
5 and 8. So y'all see these horizontal tangents? Now what are my slopes until I get to 1.5? This graph's increasing, so its slope should be positive. This graph is decreasing, so that its slopes should be negative. This graph is increasing, so its derivative should be positive. And while this is decreasing, its derivative should be negative. Those are just notes to self, okay? So now I also know that my graph is concave up, concave down, concave up, concave down, okay? So going from 0 to 1.5, I've got to make it concave up. And I must have somewhere, they told me f of 3 was 5. So we know that one. It's increasing and concave up until 1.5. So I drew it concave up and then concave down. Now it's concave down all the way until I get to 5. And do we have f of 5? We don't even have f of 5. But it's concave down all the way until we get to 5. Alright, y'all see this concave down part right here? And this is concave up. Concave up, concave down. Alright, then it's concave up between 5 and 8. And what's it doing between 3 and 7 is decreasing. So at 7, it starts to increase again. I can draw this concave up until 8. And I've got to make sure I'm doing everything I'm supposed to be doing. It should be increasing, decreasing, increasing. So from 8 to 9, it's increasing, but it's concave down. I drew it a little like this at the very end. Okay. All right, now you'll be doing some stuff in the packet that I gave you, and I also gave you another sheet. Just keep bringing those to class, okay? Also, there's a good chance you'll have a quiz on the fundamental theorem of calculus. But if I decide to do it, I'll give you some very distinct problems to study, and y'all know that the quizzes are not surprises. I mean, they are like when I tell you to study. If I decide not to give you a quiz, you'll know that.
But if we have a next class,
Yeah.
we were
If we
just.
have a quiz, it'll be next class,
We do post it.
and I'll post it. If we don't have a quiz, maybe we'll have it the next class. I'm just gonna have to look
I
and
won't be
see.
here, like, after, like, Tuesday, my last day, so.
Okay, so I'm gonna try to next class, we have one. Email it to you. Bye girls, thanks.